a work day, which is like maybe the third one we've had like all year. So the masteries you just got back. The chapter 6 mastery, which is like the whole chapter, right? Not a mini mastery, the mastery. That needs corrected on separate graph paper. Okay, we're not going over it all together as a class. You can find help in your homeworks that we've done. You can get help from me, from your classmates. Like, however you want to get help is fine, but separate graph paper. Is anybody confused about that? Because never fail, somebody's going to try to do it on their test, and it's going to make things more complicated. All right, so tomorrow you can work on the Chapter 6 revisions, or you can work on any of your Chapter 7 homeworks that need your attention. Everything for Chapter 6, except for the mastery, is in math already. Like I updated math this morning, and the masteries are going in today. Most of the time, I give you time, like a day or two, to update or like revise, and then I post grades. I'm going to call on you, but that doesn't mean distract Jesus with whatever you're saying back there. So your Chapter 6 mastery is going to be in math today. Don't freak out about it. That's too many of you are using math as your to-do list. But if that's how you're going to operate, then I'm going to put stuff in math quickly so you'll get it done. Right? So if you don't get it turned until Monday, whatever, that's fine. But like it needs done. Right? If it's a progressing, it needs revised. Vincent, what was your question?
So, since everything's started with mac and cheese, have you ever had mac and?
What? Just mac and no cheese?
Yeah.
I have not just had mac and. Well, I was about to say it depends if you cook the mac or not, but I've made I've put macaroni on a picture frame. I don't know if that would be better with cheese. That would probably not be better with cheese. Macaroni on a picture frame. All right, questions on 713. By the way, 714 is still due tomorrow. I plan to come in on Sunday to grab stuff and grade it and whatever. So we might just go ahead and put the 714 answers up today so it's in the video, because you guys know you can always go back to the video. Questions on 713. While you look at answers, I'm going to get mine out. On the back, hopefully you did 38 on separate paper. So if you don't have a separate piece of paper, you probably aren't done with this homework, because 38 needs done on separate paper. You don't have space on here to do it. I don't know if it was your class or just the other class, because we had the tornado drill, but we talked about the conversions of the speeds back here. Was that us or not? Was that us?
Excuse this interruption. Could I have Zoe Kellner and Gus jump to the Perry office for just a moment?
So for 35, somebody came up and asked me about this, and I said, we just got to talk about pizza, right? So this is like if I gave you 8 pizzas, right? So we have 8 rectangles, but then I'm going to cut each pizza into thirds, right? Which is literally how we make sense of dividing by fractions. It's cutting things into pieces that are smaller than 1, right? Divide, cut into parts that are each a third. So that is how then, if we apply keep, change, flip, that's really just like a memorization thing, right? So if we apply keep, change, flip, it becomes that. But if we look at it visually, how many thirds will I end up with? 24. Right? We will end up with 24 thirds. If we cut each pizza into fourths, will we get more pieces of pizza or less? More. And that's why if we cut into fourths, we get 32 pieces of pizza. Questions on this homework? Oh, man. So this is where, I keep having to make revisions. Copy and simple. Of course, you don't need to copy since it's already on your paper. That's if you were doing it out of the book and doing it on graph paper. But yeah, sorry. So for these, I would just, maybe you would have highlighting, right? Highlighting of like terms there, of how we get to 7x plus 1, 2x plus 1. Questions? Otherwise, I'm going to show the 714 answers. So here's what your stem and leaf should look like. Remember, guys, we said the stems are always everything but the ones place. So since this data on your homework was all in the 100s, all of our stems are going to be 10, 11, 12. So like this, 10 and 6, what number does that represent? 106, right? This 14 and 2 represents 142. Questions about the stem and leaf? And like we said yesterday, if I turn the stem and leaf sideways, it's a histogram. My histogram essentially looks like the stem and leaf looks like. Eli. Yeah. Oh yeah, I hadn't scrolled over for those, I don't think, for like D. These next two lessons are pretty much the same thing we've been doing. Well, at least what we did yesterday. So that's why we're going to try to get to 2 of them. All right, cool. I'm going to show the 714 answers, so if you guys are working on it tomorrow, Mr. Liefeld and I were talking about his computer, and I think I got the converter that he needs. So I think he'll be able to put stuff on the screen tomorrow, but obviously he doesn't have everything that I have. So if you want to check the 714 answers, come to the video at about 6.5 minutes, right? So if you want to make a little note on your 714 paper, at 6.5 minutes here in the video is where you could come and look at the answers. So I know that you maybe don't have this done yet. You maybe haven't even started this, but this homework should have the highlighting on the front talking about multiply by the reciprocal. All right, so there's our answers to 714. If there's questions that we need to go over, we can do that Monday. Because, I mean, we can even say 714 can be due Monday. Like, that's fine. I don't mind. We'll get rid of that. We'll say 714 is due Monday. Cool? I'll change it on the thing so the other class knows too. All right, so 713 is done. Turn it in. Oh, come on. Always has to drop down to a second. All right. You need out the 715 paper. Yep, for the examples from... Oh, yeah, and the math notes. So in our math notes, the part that I don't think we've really critically looked at, because I'm trying to do a part each day. All right, so 2 things we're going to look at in the math notes real quick. And guys, I already know, I'm going to say this out loud so nobody thinks I'm too crazy. I have too much planned for today. I know we won't finish everything I would love to. Like in an ideal world, I'd have an hour or maybe longer of class. And then maybe the next day we'd have a short class, right? Like that. We're talking about that sort of schedule for next year. But in your math notes packet, if I flip back a couple pages past what we've talked about, we started talking about this a little bit, but I wanted to make sure that you saw it's in your math notes here. What I would like us to label and add down here on the box plot, and you can read. You guys know how to read. You can read all the stuff they give us up here. But what I'd like to add is this is always going to be our minimum number, which here in this data set is our 2. The edge of the box is what we call quartile 1. The far edge of the box is quartile 3. The far end of the whisker is the maximum number. And what do you think the middle of the box is? It's quartile 2, but it's also called the median. And this is what some people are getting confused on, is that quartile 2, the middle of our box here, is the median. So the box contains the middle half. This box is 50% of the data. Because the point of a box plot, and I'm going to change colors of pen.
Excuse this interruption. Could I see Victor Miller in the Perry office for just a moment? Victor Miller, thank you.
The point of a box plot is that it is breaking up your data into 25% chunks. So that's why we call those numbers quartiles, is we talked about quart meaning 4. So when we're asked to make box plots, we're breaking the data up into 25% chunks. And it doesn't always work out perfectly depending on how many numbers we have. Like we talked about yesterday, if we had 14 numbers and we had 7 and 7, it got annoying yesterday. But on our example here, like if we flip back the page, right, if I flip from box plots back to here, we had a median. That number was in our data, but then the first quartile and the third quartile, these are numbers that we didn't have, right? So if we look over here at this set of data, 2, 7, 9, 12, 14, 22, 32, 36, 43, 1, 2, 3, 4, 5, 6, 7, 8, 9. So with 9 numbers, do I have a middle? Yeah, so with 9 numbers, 1, 2, 3, 4, middle, 1, 2, 3, 4. So here, wait a minute. Nobody? It's the same numbers! Aw, CPM, thanks, man. It's the same set, guys. The set we looked at over here for interquartile range and quartiles, that data set, it's the same over here. This is the box plot to go with it. So our median was our 14, but then those quartile values of 8, and what was our other one we found? 34. So notice those quartile values aren't in our data set, and we talked on the back of this paper about why, right? So these go together, the box plots and the interquartile range. Sorry that I probably should have laid this out slightly differently. I was trying to make it fit on the paper to not use another tree, right? I was trying to save one more piece of paper, so you kind of have to flip to go between. All right, cool. Today we're also getting into this stuff, fraction busters. So just to show you, this is related to what we're doing today, but we'll probably talk about that critically again next week after we've practiced some of this. Any big questions about box plots or splitting the data up into like 25% chunks? Sweet. All right, we can put this away if you want. Clip it or slide it under your binder for the time being. And you need 715 out. Oh, that is what I had out. Anybody feel like reading? All right, Kylie. Can you read the often up here? Here, I'll try to make it as big as I can. All right. Hey, Kylie's reading. So notice they're not saying the bad word. Thank you, Kylie. They're not saying the bad word. They're saying make it easier, right? So not that we can make these problems necessarily the bad word, but we can make them easier. Anybody else want to read? And this is on your paper, so you could actually read this off your paper. Farah, would you like to read the community service problem?
The Community Service Club at North Middle School is planning to paint apartments at the local senior citizen center next week. The club needs your help to determine how many apartments they should be able to paint in a day. Earlier in the year, when only 4/7 of the students worked, they painted 9 apartments in one day. Next week, all of the students are available.
So, on your paper, if you haven't realized we're looking at your paper yet, what we have here in this picture is a representation of 4/7 of the students. So whatever color highlighter you're rocking today, I would highlight 4/7 of the students, and then I would highlight down here the same colors. And I want you to chat with each other and see if you can figure out a strategy to try to determine if all of the students are there, how many apartments could we paint? So they tell us 4/7 of the students worked, and they were able to paint 9 apartments in one day, right? Here's our 9 apartments, just like a little visualization. So chat with your team, take a couple minutes. I probably can't give you 5, but I can at least make the timer keep me honest to give you a couple minutes. Antonella, did you have a question? Do you need me to come there? Here, I'll put mine into the Anybody else need highlighters? I can get more from the office later today. Make sure we're sharing highlighters with each other. I'm going to email Miss Cavalucci right now and ask for more. Yeah, this is going to need a calculator. So groups where I don't see a calculator, these numbers aren't super nice. Sadly, these numbers are not super nice. All right, sweet. Oh, by the way, Mr. Liefeld asked that I remind you, he is a math dude. Like, he does, I mean, everybody can be a math dude or do that. But he said, please ask him questions tomorrow. It's really boring when you're a guest teacher and the kids, like, don't engage with you. So he'll probably be up and walking around and, like, ask him to help you solve things. He's a smart guy. All right, so we got to use cards again. I think we're almost near the end. Or no, we shuffled up yesterday, didn't we? Isabella, can you share all what you guys said?
Well, we decided to see what one student could do. And
One student or 1/7?
1/7,
Yeah, because now this, I think you just maybe misheard the question. But this is 4/7 of the students. So we don't actually know how many students. If there were 7 students total, sure, what you're saying is true. So how did you figure that out then? If 4/7 of the students were able to paint 9 apartments, then it would make sense that if we divide by 4 on both sides, that we're going to get 1/7, right? So Isabella, what'd you guys find for 1/7? Yeah, it's 9 over 4, which is like 2.25. Squeeze a bitty 5 in there. All right, so if that's really like 1/7 then. That's like one of those little cubes. Does what Isabella told us to do. Makes sense. We had 4, so we divided by 4 and found out that like 2.25, that if I split this up into, oh, this is really hard to draw. But if I try to split this whole thing into fourths, right? Sorry, don't trust where my splits are. But that's what we're doing. We're saying split this into fourths. Boop, boop, boop. So do the same thing over there. So then what'd you do, Isabel? Or you want me to move on? So then we're going to take this number and multiply it by 7 so that I can get all of my x. All 7 pieces. So what'd you get there? 15 point... Sorry, what? So if we want to make sure that they get the apartment completely painted, how many apartments would we say? Would we round this up or round it down then? So mathematically, it tells us to round up, but this is an unfinished apartment, right? So either you're going to tell people we'll be started on the 16th apartment, or we could just say, okay, we'll get 15 apartments finished, right? Like this is where math doesn't always follow those strict rules of like how many shirts can I buy, or like how many hamburgers can I get, or like I can't get half a hamburger. Now, could I paint a part of an apartment? Yeah, I could paint like a couple of the rooms. So we could just say, sure, yeah, 15.75, this apartment won't be done. Aiden? Ooh, he's throwing out the E word, an easier way. What? All right, what do you think, Aiden? Ooh, ouch, then you said the bad word. All right, go ahead. You made it. I mean, it hurts. All right, you made it into... Okay, so I'm going to probably get rid of this stuff for right now if Aiden's taking me a different route.
And then I flipped 4, 7.
Okay.
7 out of 4.
Okay, then did what with it?
Then I times it across to get 6, 3 over 4. And when I divided, I got 15.75.
So why are you doing this?
I just felt easier for me. I don't know.
Who's our friend that we get to talk about again when I multiply a fraction? Yes, but this, guys, this makes 28 over 28, which is the giant one. That wasn't even me. Aiden took us there. That wasn't even me. That was Aiden. All right, so Aiden's right. See, now you know what it's like being me, right? When kids walk in and they're like, the giant one. That's why I just try to like lean into it and make it a thing. So, I agree with you. Like, we're all going to be okay, right? We're all going to be fine. So guys, hold up, bring it back. What Aiden just did was he said, if I multiply by the reciprocal, I now wipe out all of this stuff, and it's just 1. It's 1x. So if we multiply over here, and you told me to do this, but then I went all on a tangent. This is 63 over 4, and when you do that division, you get the same answer. And actually, here's what Aiden did. It's on your paper. Right here. Check it. Look at your paper. I want you to take a moment to think about it before we talk about it. Yeah, Aiden's like, I just did your work for you. But just take a moment to look at it and see what is represented there. But this isn't done. Aiden took us further than this problem did. We got to use another random card here in a second because I'm feeling bad. What, are you judging that I use that like a thermos? I feel bad when I don't randomize my class. So I had a mentor teacher.
You should get one of those things that you do.
But this is just a lot of problems we do are decks of cards. So, Vincent, can you tell me visually what happened from this diagram down to this one? They multiplied by 7. So they did the times 7, Aiden did. But what haven't they done yet? Aiden did times 7, but what else did Aiden do? Divide by 4. So he not only did times 7, he did divide by 4. So check it. Guys, I know this is kind of tough on your paper, because I really wish this was like erasable, but we can X them out. Check it. If we want to fill up this X up here, how many more little blocks do I need? 3. So I'm going to take 3 of these. I'm going to cross them all out and move them up here. And then the one that's left down here, cross that out. I'm going to shift it here. So go ahead and keep doing that. Cross out the blocks and then shade in the ones that we can. So I can cross out 2 more. Another 1. Oh, and then it perfectly works out that I got these 3 left. I'm going to change colors so we can see it a little bit nicer. These 3. So when we multiplied by 7, what we actually made happen, if I move some things around, we're going to write this down on your paper. I hope you still have some space. If you don't, you're going to have to go to your graph paper, but like right here beneath where it says 52, we're going to make some notes about what we just did. What we started with from up here was 4/7 x equals 9. I'm going to bring that down to here and show what we did. 4/7 x. But what did they do here? What did Vincent tell us? How many did they multiply by? 7. So watch. If we do times 7 on this side, and then times 7 on this side, what happens when I have a 7 on top and a 7 on bottom? The grande uno. Uno gigante, giant one. I need to learn how to say it in French or any other languages you guys can teach me. But these 7s cancel each other out, right? And really we're trying to change how we say that to they reduce out, right? 7/7 reduces out. So this becomes 4x equal to 63. How we can visualize that, if I can move these pieces from the bottom up to my empty pieces here, is I have the perfect amount to fill in all of these missing parts. Does that make sense? I can fill in 4 of these, and that still equals all of this, all of these 63. So now, what would I need to do to go from 4x to just x? Layla? Divide by 4. Now, Aiden actually told us to do all of this in the last problem, and he did it all in one step. And then we get x equals 15.75. So essentially, we could have just multiplied by 7/4, but this is why it works. This visually shows us why it works. Now, another way, if you're trying to color code this, oh, and I just gave away all my highlighters. If I grab all 4 of these and say I'm going to move them, they could come to here, 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 and here. If I grab these 4, they could come to here, 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 and here. And then I could grab these 4 and they could come to here, 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 and here. That's another way that I can show moving these to get 4x equal to the 63. Try 53 and 54 on your own with your team. Try them on your own with your team using calculators or whatever. 53, you might not need a calculator. You can probably do that on your own. Since we're working with a fraction here, anyone have a suggestion for what I do before I even start trying to solve the problem? Since we got a fraction on one side, Farah? Yeah, make the 8 into a fraction by putting it over 1. Lucas, you want to walk me through what you guys did?
So what you can do is you can multiply both sides by 3 over 2.
Absolutely. So if I slow it down like we just did, so I want to make sure we kind of understand the process of what just happened. Lucas is totally right. We can multiply both sides by 3 over 2, and that's the quick way. But if I just multiply by 3, kind of like they did in the last problem, that's going to give me 6 over 3. X. And then on this side, I'm going to get 24. So, because I just did this multiplication, right? I didn't reduce anything out. I didn't giant 1. And 6 over 3 is nice, right? Because 6 over 3, yeah, well, becomes 2, actually. Be careful, you're thinking 3 over 6. So this becomes 2x, and I don't really want 2x's. I want just 1, so what do I now do? Divide by 2, which I could have done up here if I did it at the same time. So now we divide by 2. If I go slowly, and we get that x is 12. Now, if I had followed what Lucas told me to do, I'll get the same answer. Let's go look at it. Lucas said instead of 3 over 1, actually use 3 over 2. So 3 over 2. What's 3 times 2 and 2 times 3 both give me? 6, right? 6 over 6. But it's really a giant one. Aiden just really wants to talk about the giant one. 8 times 3? 24 over 2. This simplifies out to a giant 1. So we get x is equal to 12. And you can write 1x if you want to, because that's just a normal 1. Instead of a giant 1, we can just write a normal 1. 1x equals 12. Questions? So guys, any fraction that you want to just turn into 1, you can use its reciprocal. And I also wanted to point out, even if this fraction is improper, even if it's an improper fraction, you can use the reciprocal. It'll turn it into 1. What about, there's a lot of Jenga blocks there. Layla Davis, what about this problem, 0.85? Because what were they doing here? Did you guys think about what they were actually doing? You probably didn't get a chance to get to this one. Do you guys need another minute or two on this? All right, work on this. First off, think about what are they actually doing? Why are they doing this? Then solve it. It's on your paper. All right, so the groups who are working, I'm sorry, but I realize we only have like 2 minutes left. What they did here, Kylie, do you want to explain it? Do you guys know? Do you want to throw us what you do know? What you do think is right? I can ask you a question if you want. If it's 15% off, what was our percent on? So the first thing we could figure out is this situation has 85% on. The 36.21 is not the price of the item before the sale. It is, you with me, Mia? This is what she paid. This is after the sale because she paid 85% and she paid 36.21. So if I wrote down just this equation, like out of nowhere, I just throw this equation to you, 0.85 times x equals 36.21. What would you, Eli, tell me to do to get the x by itself, or just get one x? Careful. If this is multiplication, we wanna divide. So guys, on your paper, please show this. We got time. You're okay. Please show this. And when we do that division, what does x come out to be? Somebody with a calculator help me out. Aiden? Can somebody confirm 42.6? Yeah? This was the price of the item before the sale. That was the original price of the item before we got our discount. So we just worked backwards to say if this was our sale price, this was the original. Hey, hold up. Amanda's going to pass out your next set of homework. So if you get all caught up tomorrow, you can work on 716 as well. 16, yeah. I'm not going to give you 17 yet because we need to talk about simple interest. If you are totally, hold up, if binders are okay, but talking is not. If tomorrow you are totally caught up on everything for everyone, 717 is over here, you can grab it, but I'm telling you, you don't know simple interest yet. So I wouldn't necessarily try those problems unless you learn a little bit about simple interest. Cool. Have a great day, guys. Please get my highlighters back up front. I am crazy running out. Thank you. My green I left over here. We'll see if Mrs. Pavlucci's going to let me have more. I told her they just keep walking away. I don't know how. They've got legs, right? Maybe they're like centipedes where they can still lay flat but just like scurry away across the floor.
They just roll away.
They roll away.